Hello, everyone. Good evening, good morning, and welcome to the world's leading digital talent transformation company, Cognixia. Myself is Raman, and I'm a DevOps trainer. And today's session, which is on Kubernetes, I'm going to conduct that. So we will have almost 1.5 hour together, and I will be discussing about the pod and pod networking in Kubernetes. Before jumping into Kubernetes, let's first talk about company. So it's a world's leading digital talent transformation company. So it is the authorized training partner for Red Hat, Automation Anywhere, ITIL, Micro, and ISC Silver Microsoft partner. So far, more than 130,000 professionals trained worldwide and deliver the training over 45 countries. There are over 7,000 industries veterans as instructors, and there are 450 plus customers. These are some offering from the Cognitia. And the center of excellence is in machine learning, AI, microservices, RPA, Internet of Things, big data analytics, DevOps, cloud computing, cybersecurity, professional development, and BI technologies. So now let us come to our topic, which is production grade container orchestration with Kubernetes. Now, in this webinar, we are going to discuss a part of the Kubernetes, which is pod. Okay, so before starting the Kubernetes, let me first talk about the containers. What is container and why containers are so important and so demanding these days on the industry level. So containers are basically where the applications are running. So that is the container. Okay. So earlier we were using the virtual machines. Now our applications are not 100%, but now the applications are slowly migrating to the containers. Containers uses very lightweight images of the operating system like Ubuntu, Red Hat, CentOS, and some Windows Core also. The most popular container or containerization technology is Docker. So the course which we are offering, that is having Docker with Kubernetes, where you will be learning in detail about the Docker, Docker Swarm, and the Kubernetes. The examples which will be provided during the training will be very much equivalent to the real-time examples. So let me first talk about the container. What is container? Then we will be discussing about the pod. Okay, so let me open MS Paint to make it more interactive. All right. So for example, you want to create a web application. So when you are creating a web application, you need to host it somewhere. You need to host it on some server. Okay. Say an example, I'm going to host a web application which is developed in Java, and it needs say Tomcat server as a uh, as a web server, right? So what I will do, instead of creating virtual machine, I'm going to in different approach, which is container. So in this container, what I'm going to do, this container is basically having the operating system plus the binaries which get installed on it, binaries of your Java. Plus it has the Tomcat installed. So these are the things which is already I have as an image. So container basically is a running Docker image. So running Docker image is called container. These images are read only. Okay, so these images are read only. Means once you create, you don't modify it. You you modify the containers, and from containers you can create the new images. So these Docker images are very lightweight images. So what is the meaning of lightweight image? So lightweight image means if we see the images of virtual machines, which is the ISO files, that is somewhere, you know, GBs in 4 GB, 5 GB, 6 GB, 7 GB, right? The image size is like that. But in the Docker, it is having say 100 MB, 200 MB, and so on. So these images are very lightweight. The reason is because it is without kernel. Kernel, which is the core of an operating system, it does not include it in these lightweight images. If there is no kernel, then how these lightweight images survive? How it runs the container? For that, the images, when it runs as a container, they are using host machine kernel. Okay, so say an example, you are running an image of Docker on, say an example, Ubuntu operating system. On top of that, you are running running a container which is nothing but the running a Docker image. So it uses the kernel of host operating system, even though it is totally isolated from the host operating system. But for the activities which is related to the container, so it uses the resources from the host operating system. So this is the idea behind the container. So containers are running images. Now let us talk about some examples of images. And first of all, let us see where these images are available, where these Docker images are available. So Docker images, you can get it from the Docker Hub, which is an official website from the Docker. And there you can find a lot of images. Almost everything you can find it. So let me just uh, go to that website. So if I say hub.docker.com. So this is the official website for the Docker. Here you can create your account uh, that is required if you want to create your images and you want to upload it on this Docker Hub. But if you don't have the account, no problem. You can still download the images. So if I say here, say an example, I want MySQL image. Okay, so here you can see there is an image which is MySQL, and here you can see it's an official image. So the official images from the Docker, you can, means I would say you can blindly trust on it. Okay, so these are well tested and it has all the features what you are looking for an image. So here you can see it is having 10 million plus downloads and 9.8K stars. Okay. Now, because it is this image is developed by the Docker itself, so it has a proper documentation as well. So when I click on this image, so you can see MySQL is widely used open source relational database management system. And for that, there are some quick references and supported tags are defined here. So it basically tells you that how to uh, run this particular image as a container. What are the commands you can use? Some of the references you can use while running this image as a container. Okay, so that we will be definitely discussing when we have our session on the Docker containers. Okay, but for the quick reference, what I just want to show you that Docker pull MySQL. So when you use this command Docker pull MySQL, so it basically downloads the image, MySQL image from Docker Hub. Okay, so this is the command line which I am using. So I'm connected to one of my server where Docker is installed. Even Kubernetes is also installed over here. So so we are not talking about the installation at this moment. We are talking about some functionality of the containers and pods. Okay. So before understanding the pods, you should understand what is containers. So that's why I'm explaining here what is containers. So if I say Docker version, so so you can see Docker is installed and 19.03.6 version is installed. So there are two components, one is client and one is server, and both get installed properly. This so far so good. Now, if I say Docker images, so when you run this command Docker images, it basically shows the images which is downloaded on your system. You can run the Docker images or you can run a command Docker image ls. So this is the categorizations on the basis of the commands. So like Docker image is Docker image. Earlier we were using the command Docker images only now, but now the new way to write this is the Docker image and then the command. If it is container, Docker container, then the command. Okay, so such kind of categorization is done, but still you can use the old way also. That will, I don't think that will never get decommissioned or obsolete. Okay, so you can see there are some set of images. So these images are related to Kubernetes. Okay, so I have already installed the Kubernetes on this system, and this is my master node of my cluster. So we'll talk about what is cluster in a bit. But these are the images. But in this list, you cannot see any MySQL image. Okay, so you cannot see any MySQL image. But I want to download an image, which is MySQL image, or maybe different one. MySQL will be little bit, you know, it's little heavy image, 500 plus MB. So if I look for the Nginx, okay, so Nginx here you can see 10 million. This is also an official image. So if you want to read the documentation, similar way means you see here Docker pull Nginx command. So uh, we can run this command. So I'm going to my I'm going to my system, and if I run this command, which is Docker pull Nginx. So what this command will do, it will download that Nginx image from Docker Hub to my system. Okay, so the image get downloaded. If I say Docker images, so you can see there is one image get downloaded, which is of 132 MB only. So this particular image is downloaded. Now this image I can use as a Nginx server. Okay, so operating system is already installed, Nginx is already installed on this system or on this image basically. So now if I want to run as a container, so let us see what is the command. Docker run -it name of the container. I will call web server, and if you want to use any port forwarding. So what is port forwarding? Port forwarding is used to map your host machine port with the container. So if you want to do a port forwarding, I'm using -p. So Nginx is running on port 80. So I'm mapping port 80 of my local system or my host machine to port 80 of the container. So this is a port forwarding. And I'm running my image, which is Nginx. And if this image is not in my on my local system, then it will be get downloaded and from the Docker Hub, and it will run as a container. So this command is basically going to create a container. And you can see this long string. This is nothing but the container ID. So if you want to see Docker and container ls, so there are some other containers are running. I'm not talking about that. I'm going to talk about this container. So you can see this is the same ID. It's a short form basically. And Nginx image. Okay, so it is running with this command created 13 seconds ago. Status is up, and I'm using a port forwarding port 80. And the name of container is web server. So if I want this container, if I want to go inside the container, so because I am using the port forwarding, so what I can do, I can go to this IP address, which is my server IP address 13.233. So if I go to 13.233 and 109.109.154. So if I go to this, and you can see on port 80 Nginx services running. So this is the example of Nginx service, but it can be any application. This is the application which is developed by you. Okay, so you can run it as a container. So your web application is running and the customer is accessing that particular web application. Okay. Now, if you want to go inside the container, you can go inside the container with the Docker execute -it, and the container name is the web server, or you can use container ID also. And I'm using the bash shell. So here now you can see I am inside the container. So root at the rate the container ID. And if I say curl, so curl command basically returns the HTTP response. If I say curl localhost, so you can see that on port 80, Nginx is running. So, so my container is running and my customer is accessing this particular website. This is well and good. If you compare with the virtual machines, what you can think that in case of same thing, so if now you create an image in your mind by saying that if similar kind of activity I need to do without container or without Docker, what I need to do, I need to have one web server that could be a physical server or it could be a virtual machine. So I need a full-fledged operating system. On that operating system, I need to install the binaries, I need to install my Nginx server. There is other way also, you can use the Vagrant boxes, but still as compared to Docker, these are not a good choice. So now your applications are up and running on a container, okay, which we have seen it is 132 MB of image. Now you can go in, means I'm inside it, I can make the changes, whatever I want to make to my application, update it, and so on. So this is well and good if you are running as a container. So I'm taking the example of Docker, but there could be any container. Now, so far so good. Let us see that if everything is fine, then why we need something else. Means I'm talking about the pod. Why we need pod, why we need Kubernetes is if everything is running fine as a container. The reason is now our container is running, right? Our container is running, which is very good. But if this particular container is stopped, who will take care of that? No one, because this is running as an orphan. It is not running as a someone is monitoring. If it is down, then I need to bring it up. Second case, if there are a lot of traffic on this particular website, so a lot of traffic is coming to this particular website, then the performance will be degraded. To solve these kind of problems, we use orchestration tool. We need orchestration tool. That's why Docker Swarm or Kubernetes comes into the picture. Okay, Docker Swarm or Kubernetes comes into the picture. So now I want to manage my container. I want that if my container is down with some reason, I don't know what could be the reason. Maybe hardware failure, maybe the internal application is in not responding mode. There could be any reason. If my container is not up and running, then there will be someone who will take care of this. And if the container is not in the running state, then it should manage it. It creates another replica of that. Or if there is a lot of traffic comes to my container, then there should be an scale up process, horizontal scale up process, where multiple containers of the same image should get created and the load on the website should be equally distributed. So high availability and the load balancing, these are very much required for any website. I'm talking about the production grade kind of applications. So Docker Swarm is the orchestration tool which comes along with the Docker. But if we compare with the Kubernetes, Kubernetes has lot of features. Lot of features related to security, lot of features related to manage your containers, lot of features related to running your containers in an organized manner. So now let us talk about pod. What is pod and how the pod is important in in the Kubernetes? So the basic unit. So if we see the basic atomic unit of Kubernetes is pod. Okay. So the basic atomic unit of Kubernetes is pod. So what it means? So it means that whenever we are talking in the Kubernetes, so directly or indirectly, we are talking about the pod. So for example, if I say replication, it is basically we are talking about pod replication. If I say jobs, so again, the job should be created on the pod. If we are talking about deployment, rolling updates, so everything here is indicating to pod. So pod is very important concept in the Kubernetes. So if you understand the pod in Kubernetes, basically you are understanding the fundamental of Kubernetes. So Kubernetes is an orchestration tool for containers. It does not support only the Docker. It supports other containerization technologies. But Docker, as it's a very demanding and very popular tool for the containerization. So that's why we have included a combo of Kubernetes with Docker. Okay. So market demand of Docker and Kubernetes is quite high. Most of the companies they are switching to Docker for their production grade application, and they are managing their applications by using Kubernetes. Okay, so now let us talk about pod. As I have created one container, which is the Nginx container, and that container was running as a web application in the uh, as a web application. So I want to manage it. Why I want to manage that I already explained you, because of the high availability for my load balancing, or someone has to take care of this. So this is running as a container. So I have a Nginx container, and this Nginx container is inside a pod. Okay, so this Nginx is inside a pod. So I'm putting one more extra security layer, you can say, outside my Nginx container. So it means you cannot directly access the container. You can access directly by going to that particular worker node, but I'm talking about the management point of view. You are not supposed to access the container directly, but you are going to access that particular container by using pods. Now this pod can have one or multi containers. So maybe you are having a pod, and in this pod you are having, say, an example, container one, which is web application, container two, which may be not a right combination, but maybe database application, database or front end and back end inside one port. So containers which are running inside the port, they are running with some service on some port number. Okay, so they are running with some port number. And now let us see the definition of ports. Ports are the smallest deployable units of computing that you can create and manage in the Kubernetes. In terms of Docker concepts, a pod is similar to a group of Docker containers with shared namespaces and shared file system. Okay, so containers we have already discussed, right? So containers are basically used for to manage your application. Okay, and to manage the containers we use the Kubernetes, and in the Kubernetes we have a concept of pod, which is the smallest deployable unit which can have one or more than one containers. You can run the pod, you can create a pod which it where it has only single container. So let me take this example. So for example, you are having one web application. So this is a container which is running on port 80. Now this is a pod. So this is the example of the pod that runs a single container. The one container per pod model is common Kubernetes use case. In this case, you can think of a pod as a wrapper around a single container. Kubernetes manages pods rather than managing the containers directly. So you are not directly accessing that particular container, but you are accessing that container through pods. Now another example of the pod, and in this pod I am having, say, an example, two containers, container 1 and container 2. It is running on port 80 and this is running on 3306. So it means this pod is having multiple container inside it. Whenever we are applying anything in the Kubernetes like replications, uh, replication is very easy to understand. That's why I'm repeatedly giving you this example. Say an example, you want to create the replication of a pod. So in this case, when you are having single pod, so it is creating a replication of the web application because inside it has one container. Whereas if you create the replication of this another pod which has multiple containers, so because we are creating multiple copy of this pod, the multiple copies will have these two containers inside each copy of that pod. Pods that run multiple containers that need to work together. A pod can encapsulate an application composed of multiple co-located containers that are tightly coupled and need to share the resources. These co-located containers form a single cohesive unit of service. For example, one container serving data stored in the shared volume to the public, while the separate sidecar container refreshes the or updates those files. So this is the example of the multi-containers where you are having one container which is, say an example, it is doing one activity and another container is doing some other activity, and both are inside one port. Now the question arises that how to access these ports, where are these ports, how these ports are uh, how these ports are basically located, how can I create a port, how can I see a port. So for that, what we need to do in Kubernetes, so Kubernetes we can write K8s also, because if I say Kubernetes, okay, so K 1 2 3 4 5 6 7 8, 8 letters in between and then S, so we call it K8s also. Okay, Kubernetes. So if you see somewhere K8s or Kubernetes, both are referring the same term. Okay, now here we have Kubernetes. In the Kubernetes, basically we create a cluster. So what is the meaning of cluster? Cluster where you have one master node and worker nodes. So we have a lot of ways to install the Kubernetes. So it depends which platform you are using for installation. Like there are some services which is provided by the cloud cloud world uh, to support the Kubernetes. We have Google Kubernetes engine, which is on the Google Cloud. We have in AWS we have a service EKS, Elastic Kubernetes Service, and Azure also we have a service for the Kubernetes. Okay, so you can use the use with Terraforms, means Terraform with Kubernetes you can use for these cloud services. You can use the Kubernetes for bare metals also. Okay, so Kubernetes concept is very vast, means it is very difficult to say that within 30 hours or 40 hours someone is finishing the Kubernetes. We can finish it, but the thing is that it is ongoing. Means there are few means you will find there are some changes are coming up. You need to upgrade yourself while means once you get familiar with the Kubernetes terms or Kubernetes resources. So there are different resources which we will be discussing in our course, like services and replica set, replication controller, daemon set, jobs, cron jobs, hard way to install the Kubernetes cluster, and how to integrate with the Jenkins for CI/CD pipeline. So all these will be the part of your syllabus. But here, when we are talking about a Kubernetes, so it has one master, at least one master, and one at least we it's not at least I would say, but it has worker nodes. By default, the 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 ports are not creating on the master node. There is a reason, that is something uh, taint and toleration concept. But as of now, you can consider that pods are not getting created on the master. pods are getting created on the worker nodes. Okay, so this is the without Kubernetes. So uh, first I need to create a cluster. So my machines, master machines or the worker machines, which I'm going to designate for my uh, for for my Kubernetes cluster, first I need to select those machines. Okay, this is my master, which have master kind of configuration. This is worker nodes, which should have the worker node kind of configuration. Once you decide, then you need to install the Kubernetes. So as I'm mentioning that there are multiple ways to install the Kubernetes. So the popular one is KubeADM. Okay. So if you want to create a KubeADM, then you can create master and worker nodes. Now these master will be as a Kubernetes master and these workers are the Kubernetes workers. Okay, so if I go back to uh, my machine, so let me clean this. Okay, so if I come out of this and if I say kubectl get nodes. Okay, so you can see I have three nodes in my cluster. One is master node, one is and two are the worker nodes. And the name of the worker node is KWN1, Kubernetes worker node 1, Kubernetes worker node 2. Okay, so these two worker nodes I'm having in my cluster. So that is what I'm talking about here. Okay, so uh, you are having a cluster, and in that cluster you are having one or more than one master nodes and the worker node. Like I have worker node 1 and worker node 2. So my containers are basically getting or my pods are getting executed over here, these worker nodes. Now, when the ports get created or when you are going to create this network, so this will not be a valid cluster until unless I define a port networking. Okay, until unless I define a port network. So port network we install by using certain plugin like Weave port network you can create, Calico you can create, Flannel you can create. Okay, so there are some plugins which we can use to create the Kubernetes pod network in the cluster. So once you define this pod network, so we are going to use Calico in our course. Also, we will use the Weave network, pod network for the hardware. Okay, so I need at least one network on which my pods can be created. So if I create a pod, this pod get created on that network. So it will be running on the worker nodes. Okay, so say an example, three pods are running and these three pods are running on my pod network. So far, so good, right? Now this pod network is having a one CIDR range. So what is CIDR range? CIDR range means it defines the IP addresses which is required for the ports. So these ports get created. For these ports, there will be some IP address, okay, which will be internally containers IP address. So these containers or these ports are running with some IP address. But what is the IP address range? That will be decided by the port network. Okay, so when we create whenever we are creating a port, so we are basically defining a CIDR range. So that is basically the port networking. So each port assigned a unique IP address for each address family. Every container in a port shares the network namespace, including the IP address and network ports. Inside a port, and only then the containers that belong to the port can communicate with the one another using local host. When containers in a port communicate with entities outside the port, they must coordinate how they use to share the network resources within the port. Containers shares the IP address and the port space and can find each other via localhost. Okay, so what it means. So say an example, you are having a pod which is having one container, okay, say C1, and it is running on port 80. And here I have another port which is having multiple containers, say C3 and C4, which is running on port say 8000 and second is running on 3306. Now, until unless we provide the IP address to these ports, so when we provide the IP address is provided to these containers also. So, say an example, if it has the 192.168.0.1 and it is having 192.168.0.2, so this is the IP address of these containers. Okay, now how they can communicate to each other? Through localhost. If C3 wants to communicate with the C4, they can communicate with the local host. But if you want to communicate outside this port, then you need to use this IP address and then the port number. So say an example, you want to connect with the container C3, then you will say 192.168.0.2 colon 8000. So it means you are referring to this. And if you say colon 3306, it means you are referring to C4. So this is how the port networking works. Okay, so there is a port life cycle. So what is port life cycle means how the port get created, what happens if it is not created successfully. So the ports mostly we are creating by using means there is an API server, and API server is on the it's a master component or control plane component also we call it. Okay, so this API server sends a specification to the worker node, and on this worker node there is one kubelet service is running, and this kubelet service is basically uh, it's you can say manager on the worker node. It takes the specification from the API server and creates the port. But there may be a problem. The port specification you are giving, it is having some problem. It's like instead of image name, instead of Nginx image, I'm saying Nginx1, which does not exist. So, so when the port is getting created, first it goes into the pending state. Okay, so first stage is pending state. So, so if it is in pending state, it means it is yet to decide whether I need to be in the running state or I'm in the failed state. So if it is successfully created, then it is in the running state. If it is failed, okay, so it's if it is failed, then it will be in the failed state. Okay, status is failed. Failed means there could be some failed error message. Okay, if it is in the running state, and after that you finish your uh, port work, then it will be in the succeeded or, failed state. So this is the life cycle. So port follows the defined life cycle, starting from the pending phase, moving through the running if at least one or its primary container starts okay. Okay, so if it is in the running, so when the containers are running without any issue, then through either the succeeded or failed phases, depending upon whether the container in the port terminated in the failure. Okay, so if it get failed, it will be failed. If it is successful, then it means when we terminate the containers, then whether it is successfully terminated or failed status, so that is the state in the once the pod is terminated. Okay, so this is the pod life cycle. Okay, now let us have a demo. So here, if I say, if you want to see that what are the different ports are running, you can run a command kubectl get ports. Okay, so I'm running one port. So let me remove this port, kubectl and delete pod and the name of the port. Okay, so this port get deleted. So we will create a new port. Okay, so it is taking a little bit time. So let's wait for that. 1, 2, 3, come on. Yes. So this port get deleted. Now if I say kubectl and get ports, now you will see there is no port running. I want to create a port which will be using a specification of an image, means I want to run a container which is having an image in Nginx. Okay, so for that the command is, let me clear the screen, kubectl, and these commands I'm running on the master node. Okay, so that things you need to just take care. So kubectl run and hyphen hyphen image, which image you want to run. Before that, you can give the name. Say, I want to create a pod 1, or means whatever the name you want to give, it should be in the lowercase. Image, and image equals to your application. So I'm creating Nginx image. Okay, now you can see image, the pod get created. So to verify this, if I say kubectl get pods, okay, so there is a problem. See, this is the problem. So it is saying error image pool. The reason is because the spelling of my image is wrong. So this image does not exist in my local download systems or my images list, or uh, it is not in the Docker Hub as well. So for that, how I can modify it? So first, let me remove this kubectl, delete pod, and the name of the pod, which is pod 1. We can update also, but that is through the script. So here, if I say kubectl run pod 1, I'm creating a new pod again, hyphen hyphen image equals to Nginx. Okay. Again, the port get created. Now, if I say kubectl get ports, so you can see it is in the running status now. It means my port 1 is created successfully. Okay. Now, where it get created? So as I have shown that kubectl get nodes, here you can see it is, I have 3 node cluster. So on master machine, it won't run. It will be either running on worker node 1 or worker node 2. So to check where it is running, you need to run a command kubectl get ports -o void. So here you can see it is running on worker node 1. Okay. And this is the IP address of my port. This is the IP address. So from where it get the IP address? From the port network. So how this IP address basically it came up here. I have used Calico plugin to create my cluster, Kubernetes cluster. And there I have used the CIDR range 192.168.0.0/16. So that is why this pod is created, and there is a random IP address with that range, CIDR range, get created for this particular pod. Okay, so worker node 1 and this IP address is assigned to this. Now Nginx is running inside this, so you can go to worker node 1. So let us go to worker node 1. Okay, this is my worker node 1, and if I say sudo su, just connect with the root user. And if you want to see what are the containers running, you can run a command docker ps or container ls. And here you can see there is one container which is 2 minutes ago it got created. Okay, and this is the Nginx container. So if I say docker execute -it, so you can directly go inside this container and this bash. So I'm inside the pod 1. See, its name is pod 1. This container name is pod 1 because this pod has created this container. Now here, if I say curl, let me see, curl command is okay. So here you can see inside the container, this particular command is running successfully because this is having Nginx. This is the Nginx container. So inside that Nginx service is running. Now, if I say ls, so you can see there is no test directory. So what I will do now, this is directly you are going inside the container, but I want to go inside this container through pod. For that, you need to go to the master and you need to write a command kubectl execute -it name of your port, which is pod 1 hyphen bash. So now I'm basically inside the container. Okay. So if I say make directory test, or let us first run this command curl localhost, it should run because I'm accessing that container through my port now. Okay. Now if I create make directory, say test demo, and if I go here and if I say ls, so you can see test demo directory get created. So which indicates that whether I'm referring through the containers or the port, I'm referring to the container only. Okay, so port through the port, most of the time we access through the pod only. We are not accessing through container directly. So we prefer to use this accessing through the port. Okay, so this is how you can access it. If you want to exit, you can exit it. You want to exit here also, you can exit from here also. Okay, so this is the one thing that by which you can connect to the you can create a pod and how to connect it. Now you can create a pod by using script also. So let me create a script, a simple script. I name it pod1.yaml. So we are going to use the YAML script to create the pod, and there is a syntax which is basically starting with the API version, and you need to give the version and kind. You need to give the kind pod metadata. So this is basically YAML syntax. Okay, and I'm giving the name of my pod as pod2, and I'm going to give a specification, and in the specification I'm defining the containers, and in this containers I'm defining the name of the container, say container 1, and I want to run an image, any image I can run. So I'm running an image which is Nginx. Okay, so this way also you can create the pod. So if I say how to create this particular pod, so you need to run a command kubectl create -f pod1.yaml file. Okay, so pod 2 get created. If I say kubectl and get pods, so you can see there is a new pod get created, which is pod 2, and it is in the running state. So let us see where it is running, -o white. So it is running on worker node 2. Okay, so this way you can create the pods by using script or by using the commands. So if you want to delete this pod, you can say kubectl delete -f pod1.yaml. So pod 2 is getting deleted. Okay. Now if I say kubectl delete and pod say pod 1 also. So pod 1 is also get deleted. So if I say kubectl get pods, so you will see there is no resources found. Okay, so that's it about the demo. I hope you like this session, and I would say goodbye here for now and hope we'll connect in our sessions. Thank you. Thank you, Vinay. So for the next session, you can just check with the support team. Thank you, everyone. Yeah, please check with the support team for the enrollment point of view. So you can check with Parveen, you can check with the support team. They will provide you the recorded session. 3 Ubuntu servers. Yes, Praveen Kumar. All right, guys. Thank you very much for attending this session. Bye for now.